Good morning. Welcome to Cloud Storage Considerations for RAG in AI Applications. My name is Scott Hoag. I'm a product manager at Microsoft in Azure Storage, specifically in Azure Object Storage. We're going to spend some time today talking about how object storage and unstructured data storage platforms, and certainly colored by my experience at Microsoft, enables AI workloads. So what are the types of workloads that need to interact with unstructured storage platforms? What are the capabilities they need? What types of clients need to be enabled to work with those platforms? And what the broad requirements are for a storage platform as well. We have performance, scale, sharding considerations, other things we need to talk about. So I'll kind of ground you all in object storage, give you a sense of what we do on the Microsoft side and how we enable AI workloads, and then we'll take a run through retrieval augmented generation or RAG and considerations for fine-tuning inference and RAG in object storage and give you a sense of what all that looks like. So let's talk a little bit about AI workloads and their storage requirements. So if I start with a storage-centric view, and I think about an AI pipeline end-to-end, at the beginning where we have things like ingestion, and at the far end, inferencing and surfacing and making those models available to customers. Everything sits on top of, for us, an unstructured data platform, Azure Object Storage. So that starts, like I said, on the front end with ingestion. And this is very similar to what we've seen for years and years and years now in traditional analytics and ML workloads, where customers need to bring in raw data in many different formats, and they need to take that data and they need to clean it. They need to run it through some kind of a pipeline to refine it. So, you know, in a traditional analytics workload, maybe some of you are familiar with things like medallion architectures and refining data down from my bronze data set to my silver data set to my gold data set. All of that still happens on top of these unstructured data platforms. Once we've cleaned our data, we need to make it available for training runs. So now there's a little bit of a data preparation and data ingestion step where we need to actually make our data available to GPU nodes so that we can run through training, do checkpointing, and ultimately take those checkpoints and persist them off for their base model weights so that we can make them available for customers to actually interact with through services like ChatGPT, Anthropic, Copilot, things like that exist in the ecosystem today. So it should look pretty familiar to those of you who have been doing analytics or kind of traditional ETL in your world. Really what's changed over time is the capacity requirements and the scale requirements for these platforms and enabling all of that. So what used to be things that could operate on gigabits a second of ingress and egress and tens of thousands of IOPS, they really grow over time to being things like I need tens of terabits of ingress and egress, and I need hundreds of thousands of IOPS. And on the capacity side, I've gone from terabytes and maybe tens to hundreds of terabytes to single-digit petabytes to double-digit, triple-digit petabytes, all the way up to exabyte scale, plus to enable this kind of end-to-end pipeline. If we think about bringing in things like fine-tuning and checkpointing and actually doing training runs along the way, we need to have this ability to offload our data from our unstructured object storage platform, bring it over to GPU nodes for training, and then be able to bring things like checkpoints back to our object storage. So all these needs around things like throughput and IOPS apply end to end across this pipeline as you're looking at it. In the world of fine-tuning, you have customers and systems that are taking these base models and they're giving them domain-specific knowledge. So they're running them through and they're effectively teaching them a new set of skills. So maybe while you have companies out there like OpenAI or Microsoft AI that are building foundational models at this massive scale, you might have a need to fine-tune a model of your own using some of the base model weights and things that come from these foundational model providers, and providing your own specific set of skills on top of a model. So for you, that looks very much the same as a foundational training run. You've got to do things like bring in training data. What's my domain-specific knowledge? I need to ingest that into my unstructured object storage platform. I need to maybe do some cleansing, things like that along the way. Bring it over to things like GPU nodes and run training runs and be able to persist my checkpoints and my fine-tuned model weights and get them out there. The big difference comes down to probably scale. You know, if you're doing foundational model training and you're working in an exabyte scale namespace, you know, that's one set of needs that we need to accommodate in an object storage platform. If you're doing fine-tuning, you might be working with a data set that is, you know, terabytes in scale. So it could be hundreds of terabytes up to a couple petabytes, but you might not be in that exabyte scale range. But we need a platform that is capable of serving all of these different customer needs, from that large end exabyte scale namespace to maybe somebody who needs a single, double-digit, triple-digit petabyte scale namespace, or maybe you just need a couple terabytes or even gigabytes of storage along the way. So if we think about the AI pipeline and kind of storage requirements, we've got this spectrum. You know, I put it on a seesaw or a teeter-totter. On one end, we have that training and fine-tuning. On the other end, we have actually serving the models out there, and either those base model weights or fine-tuned model weights, and actually doing, you know, deployment and having customers interact with these large language models. So on that fine-tuning side, it's all about that ingestion. So you have to bring your data into the object storage platform. And that data could be coming from many sources. It could be coming, like in my case at Microsoft, it could be coming from internally and things that we have within our internal systems already. It could come externally. You know, if you're somebody like OpenAI and you sign an agreement with the New York Times and you need to get, you know, the multiple years of history that are there and bring that over. Maybe you're working on AI and ML models around things like user-generated content. You could be like TikTok or Instagram with Reels, things like that. You need to bring that data over into the platform and have it come in. So we need to enable high-scale ingestion so that customers can bring that data in. Once it's in, we need to enable at-scale things and capabilities like being able to read that data and then potentially write it back out into multiple formats. You know, you could do something like ingest a very large TIFF, you know, maybe that was taken from like microfiche for an old newspaper, and all you need is the text out of that. So you need to run a computer vision model on top of it, extract it out, and just store a TXT file. So all those things need to be enabled along the way for you, and they need to be enabled in an ecosystem that already exists. So there's a bunch of tools out here that customers use, and our goal is to meet those customers where they are in Azure storage. So if you're using something like Spark, maybe you're doing like a PySpark run, we'll meet you right there and give you the connectivity and native tools that you need along the way. Once you need to bring that data over to your GPU nodes and start actually running training runs and doing checkpoints, you're going to need native integration again with frameworks that already exist. So if you're a customer who's using Torch, we want to give you kind of the best experience with PyTorch that we can. Maybe you're a customer who, you know, hasn't changed your workflow and adopted things like REST APIs or anything like that. You're just looking for native file system semantics, native file folder, POSIX like ACLs, things like that. So we want to give you clients that enable that through a native Fuse driver and bring all that together for you. We want to give you native data management capabilities. So if you think about this whole spectrum of everything from my raw data all the way over to my checkpoint data, data and my model weights, we want to give you the ability to have cost controls, things like being able to do automated tiering. Maybe if you're in Amazon and use things like storage classes and movement between storage classes for cost management. We also want to offer you a platform that has the capabilities to give you the cost controls that you need right up front. So we have multiple kind of forms of storage between standard storage and a premium object offering that is SSD backed. On the deployment and inference side of the house, we need to make sure that you can deploy your models, that load times are good, so low latency, high IOPS, things like that. We also want to give you native constructs like versioning and snapshots that you'll need to be able to enable your platform and ultimately move it forward. So for those of you who aren't familiar with Azure Storage, I won't spend a bunch of time here, but just to kind of give you an introduction to our platform, because it is a little bit different than some of the other object storage platforms that are out there. We have a block storage offering, an object storage offering, and a file storage offering. That actually all sits on a common infrastructure. So we don't have a separate infrastructure for block storage and for file storage and object storage. It's all in the same infrastructure and coalesced, and it's about the API surfaces that we offer to customers. Within our object storage platform, we have multiple offerings or multiple services. So we have Azure Blob Storage, which is a flat namespace, very similar to what you would see maybe over in S3 or an S3 compatible system. We also enable capabilities like a hierarchical namespace. So where in S3, that's, hey, go over to a different bucket type and one zone express and things like that. In our world, it's the same storage account. It's just a checkbox and an API that we allow customers to call to go from a flat namespace to a hierarchical namespace. I need atomic folder deletes. Great, flip the knob and you can have that happen. So that's our Azure Data Lake storage offering. It's actually a super set of capabilities that sit on top of Azure Blob Storage. We have unique offerings in our object storage platform when it comes to things like choosing your performance. So we have an SSD-backed storage offering called Azure Premium Blob Storage, and then we have our standard storage offering that exists out there. And then the other unique thing that we do is multi-protocol access. So beyond being able to enable a flat namespace and then transition to a hierarchical namespace, in real time, on the same storage account and on the same system, we also offer multi-protocol access. So you can do things like HDFS and NFS on top of that data and have multiple clients interact with it, reading and writing and really enabling this end-to-end flow of things that are out there. And then we bring this subset of capabilities that's common across the platform. So once you start using it in one place, say maybe like a data management capability like lifecycle management, you can use that for your data in your flat namespace and your hierarchical namespace. It's the same lifecycle management engine. It's the same set of rules that are interacting on top of your data and helping you kind of just be in the same place and enable your workload very easily. If you think about things like ingestion to the platform, like I said, data lives in multiple places. We offer services like Azure Storage Mover that let you bring your data from on-premises to Azure Storage, from SMB and NFS protocols up to object and make that transition. Azure Storage Mover also has capabilities for moving data from S3 and over to our platform, and we'll continue to expand that to other object storage providers over time. We have low-code, no-code platforms for enabling data management, like Azure Storage Actions. So some customers don't like to write complex rules and define lifecycle management rules in JSON, and they don't have needs to run them all the time. They might say, hey, I've got 100 million objects that I just need to tier from hot to cool or cold, and they can do those things in storage actions through basically a no-code interface and an easy deployment mechanism for their kind of single-time runs or multi-time runs. I talked a little bit earlier about speeds and feeds and kind of what we need to enable in our platform. So I got some numbers on the slide. That's our entire storage platform. all up, where we are driving greater than 600 terabits a second of throughput across the platform. We bring in over 200 exabytes a month. That number continues to grow as our customers get bigger and as these workloads get bigger, and as more and more customers come in net new to the ecosystem and start to onboard. So we can always talk about speeds and feeds later, and if anybody has any questions, we'll get into that towards the end. I do want to take a minute and kind of talk about this multi-protocol approach that we have in our platform. It is very unique, and it is a differentiator for us in that we enable customers, again, in a single namespace and a single storage account, to light up all of these capabilities. So if you start on a flat namespace, that's great. That's our RESTful API surface. Maybe you're using our existing clients and our SDKs to interact with that to make your life a little bit easier. But if you're not ready to transition to a RESTful interface, maybe you're just an analytics customer and you're in the Hadoop ecosystem. Well, we're in Hadoop as well. We have a native Hadoop driver for our platform, the ABFS driver that's there in Hadoop distributions and available in Databricks and Snowflake and all the major analytics platforms. We enable NFS capabilities on Blob. So internally, we talk about it as Blob NFS. Externally for customers, it would be NFS v3 on Blob. So if you have that need and you want to access that, we can absolutely enable it. We also enable SFTP on our platform. It's not a different storage offering, anything like that. Again, it's kind of a knob and a lever that you just flip a switch, and you can have SFTP. The really nifty thing about the way that we kind of look at multi-protocol and the way we do it is it's one storage account, multiple protocols, and multiple clients accessing it. So you can have the ability to say, load your data over something like SFTP. I have an external provider. They need to send me a bunch of PDFs so that I can do RAG on top of them. Great, here's an SFTP endpoint. Go ahead and ingest that. And then you can make that data available over things like the REST APIs. So you can just do a git blob and grab that data. You don't have to do anything special along the way. You can write your data over NFS, read it over in your analytics platform. It is really mix and match. And then because it's all a common storage platform, that means you get the foundation of things like lifecycle management and data management capabilities with object tiering and lifecycle policy management. Security is a common construct across the platform. So we do things like OAuth through Azure Entra ID on the control plane and on the data plane. So your auth-z and auth-n all come through a common construct, making it super easy to secure your platform. If you think about maybe something like a logical firewall, it applies to all of the data that lives in your storage account and all of the clients that access it. And then we also allow customers to select their durability. So if they want to be zonal, we have capabilities like zone redundant storage or ZRS. We also have geo redundant storage or GRS, where we allow customers to asynchronously replicate their data between two regions that are greater than 300 miles apart. So it's all just kind of there and built in on the platform and ready to go for customers. So when you think about kind of having this platform and multi-protocol access and everything that's going on, ultimately you need to build applications on top of it. And that means coming in over these protocols and then figuring out which side of the fence you're on, or maybe you're on both of them between AI training fine-tuning, or you're more on the inference and RAG side of the house. But you need to have clients that enable access to all of this. So on that front end side, I talked about analytics. So I won't beat it down too much, but we are in that Hadoop distribution. We have a native Hadoop driver called the Azure Blob File System Driver, ABFS. Works over both a hierarchical namespace and a flat namespace. That's a new capability that we recently added there. But bring your analytics engine of choice and your compute of choice, and you'll be able to interact with the data in your storage account. You'll be able to interact with that data at scale. We'll help you grow over time automatically with no changes in SKUs, no additional pricing or anything that will carve out across the top. We'll do that at what today for us can scale all the way up to tens of terabits for external customers, which is really amazing. Like when I joined the Azure storage team 5 years ago, we were doing tens of thousands of IOPS and tens of gigabits a second of ingress and egress, and that's rapidly changed over the years, where now we're doing terabits a second of ingress and egress, and we're doing hundreds of thousands of IOPS all on top of an object storage platform. And you kind of need to do that. If you think about that end-to-end workflow, we want to enable that all in a single namespace and a single storage account and have customers be able to interact where they need to. On the RAG side, we need to think about integrations. So as an object storage platform, I don't have a vector database or some of these other tools that are needed to enable inference and retrieval augmented generation. So in Azure land, we have native services for that. So things like Azure AI Search, Azure OpenAI Studio, AI Foundry, or you can also bring your own. So if you're a customer that's out there today and you're using Pinecone for vectorization and you're using maybe something like LangChain or PyTorch in your ML workflow, we're there as well. Sometimes it's not apparent that we're there, but we actively contribute to things like LangChain because we want to make sure that it has the best integrations for our object storage platform so that we can meet our customers where they are. We'll get into it a little bit later, and we'll kind of take a deeper dive on it, but these RAG applications also have needs around low latency access. Often smaller IOs are occurring in RAG than they are in other parts of the pipelines. We want to make sure that we can enable that across the board. And then data freshness becomes really important, especially in RAG. If you think about having maybe a container or a folder of documents that you are going to use in near real time to supply new facts to a large language model, that data set could be changing. Oh, that set of PDFs that I had yesterday, it's different today. Well, that means we need to have enabling features like change feed and eventing so that systems like maybe Azure AI Search can go ahead and perform their vectorization automatically and always have the most up-to-date indices and be where they need to be. And then again, across that spectrum, we enable that common foundation that's out there. I want to talk a little bit about scaled accounts. So this is a capability in our platform that enables us to take a single storage account, like I said, from a small scale all the way to a large scale in place. So the way we do this is by going through horizontal slices in our platform. So if you think about a storage account that maybe starts its life on a single scale unit and a single slice, as the needs of that storage account change, so it starts to have higher throughput needs, it starts to have higher IOPS needs. As we see the clients interacting with those storage accounts and their needs changing, we take them and we automatically scale them across our platform. So we start to add more scale units and more slices out there to give customers more throughput, more IOPS, and better performance on top of their storage accounts. It's all automatic. There's no change in SKU. There's no change in pricing, anything like that. It's transparent to customers. In most of the time, they don't even know that we're doing it, and their workloads continue to operate. So we're always load balancing within our platform and enabling the capabilities for customers that they need today. So we're in a world today where maybe if you go into Azure and you look at our documentation and you say, okay, a default storage account gives you 200 gigabits a second of egress and 60,000 IOPS, that's just where we start. And from there, we kind of grow with you as you grow in your platform. So that's a really cool capability that we have that it kind of enables customers to be in that single namespace and grow over time. We've publicly demonstrated this for external workloads. So most recently at Build this year in May 2025, we demonstrated a public run on an AKS cluster with 10,000 plus nodes. I think it was about 350 50 pods running the HPC IOR benchmark test. So we went through and ran that, and we were able to get over 15 terabits a second of ingress and over 25 terabits a second of egress. And that's just where we were in May this year. We continue to grow and we continue to scale the platform on our side. The other really cool thing about this is we do this with no specialized clients or anything like that. We have a Fuse driver called Blob Fuse. It's available through native CSI interfaces. So customers can go ahead and spin that up. And this is just our Blob Fuse client running through CSI on an AKS workload, Azure Kubernetes service, and being able to achieve these kinds of things. So it's not any special API surface, anything that you need to change in your applications. You don't need to adopt a new client, anything like that. It's all just a native mount on Linux along the way. I want to talk a little bit about our clients and kind of how we enable customers to interact with the platform. So, we have that Fuse client, Blob Fuse. We also see a lot of customers that have data movement needs, particularly data movement needs maybe between storage accounts or between regions as they're doing things like chasing GPUs and trying to follow the compute where it is. So we have a unique API in our platform called put block from URL and put blob from URL that enables service-to-service copies, where you can take an object that lives in storage account A in region A, and you can copy it over to a storage account in region B and storage account B, all without any of the data transitioning through your client. You don't need to download it and re-upload it, anything like that. Our scale units, those same scale units and slices that are doing things like scaled accounts, they also have capabilities on the back end to just talk to each other and enable those copies in data movement scenarios. So today we have things like AZ copy, basically a Swiss Army knife command line utility that allows customers to very quickly hop into a terminal or a shell and copy tens of millions of objects between storage accounts. You can run multiple AZ copy jobs at the same time on multiple clients, all the way up to the throughput and IOPS of your storage account. We've seen customers that have transferred petabytes a day between regions, and not just single-digit or double-digit petabytes, but triple-digit petabytes, as they're moving data sets and trying to get data to where it needs to be for researchers, for their analytics and training runs and other needs that they have out there. Blob Fuse is also a client that we make available. This is the Azure storage team that builds all these tools and kind of make sure that they do what they need to do for customers. Blob Fuse is a Fuse client for Linux, available for all the native Linux distributions that are out there. It is just an ATP Git or a yum install away for you if you're on RHEL. And the other thing is you can just go and run this as well in things like a native CSI driver and have those capabilities there too. So Blob Fuse has a number of capabilities that enable the kind of AI ecosystem, whether it's on the training side of things or whether it's on the inference side of things. We recently announced a capability in Blob Fuse that we call Preload, which enables customers to do a native mount on a Linux client, and for that large namespace, that exabyte scale namespace, will make available to you stubs for the files as immediately as you can, and then as you start reading that for your training runs, we'll go ahead and bring that data to you directly. Again, at terabits a second of scale and hundreds of thousands of IOPS. Blob Fuse is a really unique client. We spent a bunch of time on it to make sure that it can fully utilize the resources of the node or client that it runs on. So that means things like if you put Blob Fuse on some of our larger Azure VMs that have NICs that are capable of 100 plus gigabits a second of throughput, Blob Fuse can use all of that throughput and all the I/O on the NVMEs and the local disks to bring your data to you fast and to allow you to also push your data back to object storage as fast as possible. We also have a PyTorch connector. We're kind of deeply embedded in the AI ML client tool space. So PyTorch is one that we put out there from our team. Again, built by our team, fully staffed, fully funded, has native capabilities in Torch. So if you're a PyTorch customer today, all you have to do is plug in our connector, and you can continue loading your data sets, saving your data sets, and performing ML and training your models as you've been doing, and just kind of a quick plug-in interface. We also contribute to a number of other clients in the AI ML ecosystem. They're not directly owned by our team. They're pure OSS. So that's things like FSspec. We want to make sure that customers have the best experience with blob storage there. So maybe if you're using FSspec in LangChain, we're also involved in LangChain and getting those out there, and we'll continue to kind of expand in that ecosystem and get more involved over time. We want to meet developers, data researchers, and everyone where they are with the tools that they use today. So let's go ahead and kind of talk about RAG with object storage and some of the specific needs there. We talked about kind of the perf and scale and the end-to-end pipeline. So let's go talk about kind of the end of that pipeline and retrieval augmented generation. So this is all about bringing domain-specific knowledge to your large language models. And this is done in kind of three ways, if you think about it. So one is prompt engineering. So, if folks have ever gone in and they've looked at the guidance that comes out from Anthropic or OpenAI, they actually tell you very well how these large language models work and the things that you need to do. Turns out prompt engineering is this skill that folks need to build over time. So if I'm working with an LLM, I can certainly do prompt engineering and bring knowledge on top of that base model. So I can give it in-context information. I can say, maybe give it a role, give it a set of goals, give it a task to be done. What are the outputs that I want on it? So I'm a product manager. Maybe I go in and I prompt an LLM and I say, you're a product manager with 20 years of experience in building and deploying REST APIs. We're looking to build a new REST API that has these capabilities. Maybe I want to write a PRD or something like that. But I have to bring all that knowledge to it every single time. Fine-tuning is about bringing new skills to your LLMs. So you take that base model and the base model weights and you say, okay, I want you to actually have a new set of capabilities, and I want you to be really dialed in for a specific, a domain-specific knowledge data set. So that could be things maybe like healthcare. Like we've heard for years about companies that are taking models and fine-tuning them and training them to help with things like cancer research. It could be helping with finance. It could be helping even just fine-tune a model maybe to help you code faster within your environments. And then we have retrieval augmented generation, or RAG, and that's where we're taking these models, either these base models or fine-tuned models, and we're actually having them learn new facts in near real time. So taking something and saying, okay, great, I trained that model on domain-specific knowledge about my company and I have that data set in there, but maybe that data set gets augmented or it has new things that you want to bring in and provide context to the LLM. You can bring that through retrieval augmented generation without having to retrain your model along the way. So RAG, or retrieval augmented generation, it's all about combining reasoning with the knowledge that already exists out there. So we have this fine-tuned model, and we want to be able to bring data from multiple data sources, again, in near real time, and have it augment the response of those LLMs as it's coming back. So in my world, that's Azure Object Storage for unstructured storage. Customers that are out there, maybe in a more structured storage offering like SQL or Azure SQL or their database of choice. It could be a NoSQL engine like Azure Cosmos DB. We want to be able to bring all of that data in, chunk it, vectorize it, and then make it available to those LLMs. So if we go back to that AI pipeline, and we start to think about a storage-centric view for RAG, what was in the middle before, reading data and checkpointing data and pushing out a set of new weights for fine-tuning, now it turns into data chunking. So I need to ingest this data, I need to generate embeddings, and I need to push those embeddings over to a vector database, which is an offering that's external, at least in our world, to Azure Object Storage. And then that vector database needs to have query capabilities so that it can do vector similarity searches. So if we think about unstructured storage in that world, that means things like maybe bringing your PDFs, your Word docs, your images, your TIFFs, your CSVs, whatever it is, into unstructured storage, being able to run them through an engine or some type of service that can generate those embeddings, push those embeddings over to a vector database, and then kind of rinse, repeat. Data freshness becomes really important here along the way. So as you're adding new objects to that unstructured data set, you want to make sure that the engine that's doing the chunking and the vectorization is aware that there's new data in there so that it can constantly update its indices and have the most native and near real-time capabilities for users that are querying your LLMs. So you have a number of requirements that come into play for these systems. You want to be able to bring your enterprise and domain-specific knowledge in. You want to be able to do that in a secure way with authentication and authorization, and you want to be able to do that with existing clients or clients that have capabilities with the protocols that you need within your platform. So for us, again, that's that multi-protocol approach that we have to enabling customers in our world and bringing multiple clients and native capabilities for them. You also want to have a native integration, if you can, with things like your vector databases. So again, they need to know that new data is landed and that data is fresh and it's ready to go, so you're getting timely updates to those indexes along the way. And you want to make sure that it's secured end-to-end, not just for your users who are loading data in, but also for that vector database or that engine that needs to talk to your unstructured storage as it sits out there. So if I think about RAG with blob storage within our platform, it's the multi-protocol story, it's the low latency access. So if you need things like lots of small IOs and you need time to first byte and latency to be measured in single-digit milliseconds, we have this SSD-backed offering that can bring that to you with Azure Premium Blob Storage. It's native integrations with vector databases and systems that can do the chunking and vectorization and provide vector similarity search for you. Or, if you don't want to use those native integrations, you can also bring your own. If you're a customer and you're doing Pinecone and LangChain today, Pinecone and LangChain work great in the Azure ecosystem. Like I said, on the LangChain side, we're actively contributing to it, making sure that it has the best set of capabilities. We look at Pinecone the same way and contribute to all of these projects that are out there. So, not to beat it, but we want to meet you where you are with the clients that you use today, the protocols that you use today, and the types of access that you look for today with your data. In our platform for data freshness, we have capabilities around generating events when new objects are loaded in our platform and integrations with Azure Event Grid and Event Hub. We also have a capability that we call change feed, which is a durable ordered list of changes to your storage account. So what that means is if you have a namespace that's out there and you're loading objects into it, as you're loading new objects in, we can give you that durable ordered list of saying, hey, here's a new object. We can fire off events to these systems that can respond to them, like Azure AI Search and AI Foundry and other things that are in our ecosystem. And we can keep them up to date in near real time so that they're constantly running through that kind of workflow of generating embeddings, updating indices, and getting them where they need to be. And that's all in a common identity system. Everything's driven by Entra ID integration, so it's all OAuth. We provide role-based access control, even on our data plane, and we also augment that with things like attribute-based access control. So you can go and say maybe start with role-based access control, and then we allow you to do things like apply metadata tags. So we have these things called blob index tags, and you can put maybe like a project code on that. And then that user who's accessing it, their security and their access to that would be augmented by that attribute of a project code or an IO code or whatever it happens to be that you want to push on. So RBAC plus ABAC and that role-based access control and attribute-based access control is a really cool capability and unique within our platform. Talking a little bit about Azure Premium Blob Storage. So it's SSD-backed object storage. It is low latency, and it is consistently low latency. So if you look at kind of like P99s for latency and time to first byte, it is excellent. It is really good for small object IOs. And when I say small object, I'm thinking in the kind of kilobyte to single-digit megabyte range. Time to first byte for this platform is measured in single-digit milliseconds. And like I said, it's consistently there. The other thing that's interesting about this is if you have lots of small objects and you're driving lots of IOs, that means you're driving lots of transactions, and transactions cost money. So customers can realize some real cost savings and cost benefits on this platform as well. So if we think about some small IOs, just as an example, so let's take some 400 kilobyte PDFs and compare them to our standard offering and our premium blob storage offering. So if we think about the RAG pipeline and needs around things like data ingest and chunking, well, we need to go ahead and do put blob requests. We need to write those new objects in. So for small IOs, premium can be up to 2 times faster for you. On the vectorization side, where you need to do a get blob request, or an S3, it would be a get object request, and you need to pull that in for vectorization in premium storage for us, that's 3 times faster. And then you also see that benefit for just retrieval of those objects in general, whether it's integrating with Azure AI Search or one of the native platform services, or you're just coming in over a single client, HDFS, Fuse, over the REST interfaces, anything like that. And so you can realize these benefits, right? Up to 3x faster on writes, on reads, 3x faster, or 2x faster on writes, 3x faster on reads, and significant savings on transactions. So when you compare the cost of transactions on our hot access tier to those on premium, if you're doing a lot of small IOs and things like this, you can realize some real cost savings by potentially transitioning over to premium blob storage. So if we think about where we are today in the present with kind of AI pipelines and vector databases, we've talked about a bunch of different things today. So we have that disaggregated and scaled out storage architecture through things like our scaled storage accounts, meeting you with clients where you need to be. If you're doing AI training, you don't need to build a custom client, pick up one of our SDKs, wrap our REST APIs, anything like that. You can just get started with Blob Fuse today, and you'll be up and running in minutes and kind of ready to go. You need those analytics engine integrations. So for us, that's our ABFS driver being directly integrated into the Hadoop ecosystem, and it's meeting customers where they are with the clients they need. You don't need to pick up our SDK and write something custom. You can just grab our PyTorch connector. If you're already using PyTorch, you can just grab our LangChain modules and get up and running and be where you need. Or maybe you're just doing FSspec. You can just pick up our FSspec implementation in ADLFS. And again, you're up and running. We build those. We make sure that they're the most performant, that they're fully supported, and that you can reach out to us when you need help along the way. And then we think about that vector kind of database side of it. So the other thing that happens there between these systems having to do puts and gets for chunking and generating their embeddings and pushing everything over to a vector database, the vector databases themselves also use object storage to offload their indexes. So that's native platform capabilities in Azure, like Azure AI Search. Again, if you're doing Pinecone, you can just take that index and also store it on the same object storage where you're storing all the other things that are enabling your workflow along the way. So let's kind of talk about our key takeaways here when we think about building AI apps on top of object storage. So if we go to that AI training and fine-tuning side of the house, which many of us actually kind of do end up in as we're trying to get that domain-specific knowledge into our LLMs, it's about being scalable. Everything from kind of petabyte scale to what is exabyte scale and ever-growing today. It needs to scale in those dimensions of capacity and throughput and IOPS, and scale with clients and workloads in place with no disruption to connectivity, not needing to change the underlying components or underlying clients. It needs to be cost effective. So we need to have things like in our world of access tiers between premium, hot, cool, cold, and archive. If you're in an S3 compatible ecosystem, you'd be using storage classes and things like that for the equivalent over there. So you need automated lifecycle management. We provide that through Azure Blob Lifecycle Management today, where customers have a rule engine they can use. We also have things like storage actions that I talked about that allow you to do at scale, and when I talk about at scale, tens of millions, hundreds of millions of objects of retiering, setting metadata, all those kinds of things within our platform. Everything needs to be integrated. I can't stress enough, you need to meet customers where they are. That's the thing that I think about a lot as a product manager in Azure Storage and working with our developer experience teams. We want you to be able to pick up native clients, native protocols, and native access mechanisms without having to fundamentally change your workflows, change your applications. You'll just be able to get up and running with the things you use today. It needs to be interoperable. So we need to be able to interact with GPU nodes. We need to have file and folder semantics, even on flat namespaces. We need to offer you things like POSIX like ACLs, or even like native mount points on Linux clients, things like that. On the RAG side of the house, we need security, right? We need identity-based access controls for both authorization and authentication. And that comes down to maybe not even just like the end users who are interacting with things, but because these are all disparate pieces, right? We have a little Lego block here and a Lego block here. So if I think about a service like Azure AI Search, I want Azure AI Search and the instance that I deploy to have its own identity. And then I want to be able to give the identity access to my object storage and have it come through with the access it needs. And that can be in the form of role-based access control, or it can be role-based access control and further augmented with attribute-based access control. We want that native integration with all of our SDKs and tools that exist out there. So if you're using Azure AI Search for vectorization, that's great. If you're using Pinecone, or another system, we will meet you there as well. We have these unique capabilities like Azure Premium Blob Storage that allow for that low latency access. I think that is super important, especially on the RAG side of the house, where things are much smaller IOs than they are in other parts of that AI pipeline. And then we've got that data freshness aspect with things like change feed and change notifications in our platform. Again, super important for RAG. You don't want customers to go ahead and if I think about an experience, maybe like Microsoft Copilot, where I can put a bunch of documents into a notebook. I don't want to put documents in that notebook and then query the LLM and not have them available to me very, very quickly. That's a key part of the customer experience that you need to consider as you're building your RAG applications. So thanks for spending the time with me, learning kind of a little bit about object storage and how you can enable the end-to-end view of AI from ingestion and training all the way to the far end of inference and RAG. And I hope you all enjoy the rest of your conference. We got a couple minutes left. Any questions? If not, I'm at the conference as well, and we've got a bunch of folks here from Microsoft. We're happy to answer your questions. Yes?
I'm not sure if you can answer that quickly. Let's say if you want to use RAG to embed the whole repository and our source code file, you have to go out there.
Okay,
Yeah, I'll repeat it. So the question was, how would you do RAG with tens of thousands of source files for source code? Tens of thousands is kind of small. That's not a lot. Let's do hundreds of millions. Let's do multiple repositories and billions of lines of code. So I think a lot of that comes down to thinking about things like I/O size. Like, how am I going to ingest that in? So I don't know. Maybe I've got a large code base in .NET, and I've got a lot of .cs files, things like that. Those are going to be kilobyte sized, and I need to load them in rapidly. So like in my world, that would be things like premium blob storage to enable those really fast IOs on those small objects and bring them into that system. And after that, it's vectorization. So what are you going to use to do that? So systems like Azure AI Search, they kind of scale as you're loading data in with the eventing kind of change feed and notifications that we have there today. So if you're loading 10,000 of those a second, it's firing off in the background immediately and doing the vectorization across those. You might need to think about those things a little bit differently, if you're using Pinecone or another vector system that's out there, but it's totally doable. We certainly do it. Yeah. Yeah. So the question was, I'll kind of simplify it a little bit. So the question was, if you have data that's stored in that high performance SSD backed storage account, premium blob storage, how do you take it and realize cost controls and be able to move it from premium blob over here on SSD over to that HDD standard offering and maybe get it into hot, cool, cold, things like that. So that data copy scenario, it'd be a copy scenario for us today. So a premium blob account is one account, and a standard account is a different account on that side. So for us today, the way that would look like is copying the data from the premium account over to standard, and then doing kind of your tiering and lifecycle management over there. I'd love to talk to you more maybe about the needs there. We think a bunch about it, like do we need automated tiering or things like that. So today in our platform, you could do that with AZ copy, that command line utility. You could also use things like if you were looking for like, hey, I don't want to write a script, I don't want to write an application, you could just use things like Azure Storage Actions to do that for you. And Storage Actions isn't just about copying data or setting metadata about it, it's also things like allowing you to delete, generate versions, generate snapshots. So you could take that data set, okay, I've run my run on top of it, and I've generated my embeddings, I'm ready to copy it over here, I'll just run a storage action, and all in one, that will go ahead and copy your data over, and it could delete it and clean it up and do those pieces as well. All right, so I think we're mostly at time. I'm at the conference. I'm over in the object storage platform, object storage plugfest rather. Happy to chat more with folks, or if you have any other questions about our platform. Like I said, we have a bunch of folks from Microsoft here. So thanks again for taking the time to come in and joining me this morning.